Hey guys, I'm just putting together a little FAQ demo for you guys because a lot of people, I went to bed last night answering a bunch of questions about this product, woke up, I got more questions. I just want to walk through a couple things that I may not have taken the time to fully express when we went over this in class. Now that you've had a chance to try to get your feet wet and use it a little bit, you can perhaps see how some of the stuff I'm going to explain to you makes a little bit more sense. Um, by the way, pardon me that I'm underdressed. I just sort of woke up and I'm wanting to get this to you. Didn't bother to put on the tie. Apologize. But let's just get to it. So first page, make sure you put your name and your section number and all that stuff here. Make sure you do that. Second set of questions came dealing with this particular section. What do you do for these z-values? Well, if you can put these z-values on here to 3 decimal places, that'd be great. I know our table from our textbook doesn't go to 3 places for z-values, but if you can use any of the different Excel formulas that are available to you in Excel, that's where they're available, then you might be able to just do that automatically. Though looking it up in the table, I think is a pretty efficient short-term solution. The part down here, we went over how to fill in at least one of these cells. I know some people have mentioned, it may or may not be true, it's probably true because a bunch of people have mentioned it, but that when you get to certain levels of alpha, that it's not possible to find a t-value less than 2, even for a large sample size, large degrees of freedom. In that case, go ahead and just tell me NA or something like that, or can't find it, or grr. So the main questions that people had for me though dealt with Q1 and Q2. I'll just try to go through how I would attack in further detail these types of questions. I think this was the section down here that a lot of people had questions on. So this is the population column. It's the baseline. It's the column by which everything's going to be compared. I'm going to freeze panes. I've highlighted this column here. I clicked on C. Oh, that's not the one I want. I'm going to unfreeze panes. I'm going to do this because it keeps my mean right where I want it. So I clicked on D here where sample is, the word sample, and then I hit freeze panes, and now, well, those things on the left aren't going to move, and that's pretty good because it's my baseline. Assuming you've already gone down here and, let's say, populated some data. I don't know if this is the actual cane data. I think it is, but I don't know. It's up to you to find that stuff. 52 things? I think that sounds right. Maybe. I got to populate some of these statistics up here. Mean, standard deviation, sample size, standard error. Well, I've already got these equations here. I can just copy and paste them over. All I did was highlight, copy, paste. There's a problem with that, though. There's one very obvious problem that comes from one of those 4 statistics not being computed as a statistic. So that's my hint to you. Copy and pasting those over is accurate for some, but not all of these metrics. The hint being parameter versus statistic. Moving on. These 4 questions are the ones that seemed to cause the most question. Again, the purpose of this project is for you to systematically, in Excel, answer a bunch of questions as to how these different sample groups, whether it's a dealership or a type of car, etc., compares to our baseline population of everything. Now, you can make a directional hypothesis, or you can make a non-directional hypothesis. If you chose to make a directional hypothesis, you type yes, and that is to say, I'm going to hypothesize that my sample mean is either less than or greater than, you're going to pick one, the population mean mu. If you hypothesize that it is less than mu, then you could type less than. Pro tip, use 2 hands and then it goes quicker. If you chose less than, then you're going to be doing a one-tailed hypothesis test. If you chose a non-directional hypothesis, you're going to choose a two-tail. Well, what's the point here? Why choose less than or greater than or whichever? Well, you can see based on this sample mean, if this sample mean is correct, based on this one, that the sample mean is less than the population mean. Now, technically speaking, in your research process, you should decide before you collect your data whether or not you're making a directional or non-directional hypothesis. Maybe you've got some previous research from the assignments we did earlier in the semester. Maybe you decide you're going to, I don't know, create some sort of weird loop in that process and say, you know what, I've got the sample mean. Now I'll decide whether it's a directional or non-directional hypothesis. I'm going to decide directional. I'm going to decide directional in the direction less than the population mean because this number is less than the population mean. You know what? I've got no way to know if that's how you made your decision. Why would you go with a one-tail over a two-tail hypothesis? Because it's quote-unquote easier to reject than null because your critical values are closer to the middle. Excuse me. It also generates smaller p-values because you're only having to include one side of the distribution. You only include one tail. You don't double it like you do for a two-tail hypothesis. Why all that noise? Because if you do decide that you're going to, let's say, do it once and then copy that formula over for all of the other things you do here, and then you decide you're going to paste, oh, I don't have any data down there, so it doesn't work. Maybe you do the same thing down here. But if you do the same thing down here, your directional hypotheses may be a bit screwy because sometimes it should be less than, sometimes it should be greater than. Maybe you just decide, nope, no directional hypotheses, no direction at all, so then I'm going to do everything here, and if I come up with a formula for p-value that I can use Excel for, which I'm going to in a second, and I can just straight up copy this across and I'll be done. That's not insightful, but it's certainly efficient. Let's say I've decided I'm going to make a directional hypothesis that my sample mean is less than my population mean. And a couple next steps here. If you're going to do a hypothesis test, you need a test statistic and a critical value. However, this isn't set up for test statistics and critical values. It jumps right to the p-value. Part of the philosophy that I have that doing the critical values doesn't make as much sense. Well, if you're going to compute a p-value, the only thing that goes into a p-value is the z-score. So if I have a test statistic, I can use one of Excel's formulas to convert that test statistic into a p-value. So let's use that formula. So a couple parts of it. One, you have to use the complement of, here's one that works, norms dist. So all I need to input here is a z-score. By holding Alt and hitting Enter, you can carriage return down a row in your formula bar. That's why my formula bar is always like 4 deep, because that way I can organize all of my different formulas. See, now I know that I'm going to do 1 minus whatever function I include down here. The reason I've included another row is because I'm now going to put in the expression for the z-score. That way I don't have to do it in multiple rows. I can cram it all in one. You, however, maybe it's beneficial to you to say, I'm going to create z-scores and I'm going to put them in this row. And that's fine, because then you can just input that z-score and use the complement of the norms dist, and Bob's your uncle. Me, on the other hand, I do things this way. Z-score is the sampling error minus sampling error divided by standard error. Standard error is the sigma over square root of n. So you can't use that standard error here. You've got to make sure you calculate your own standard error. Now I need sigma, which is the population standard deviation, divided by the square root of my sample size here. We had an extended discussion the other day in class about when to use the $ for static cell references and when to leave them dynamic. Here's a great opportunity for you yourself to include the $ in a place that would be appropriate for you to make this work. So assuming that I did that part right, assuming that anything here that should be the way it is good, then we're all right. Is this a one-tailed test? Is this a two-tailed test? Do I have the right values up here? Should this be 1 minus norms dist? Should it just be norms dist? Are there other ways that we can do that? Ultimately, we can check our work by calculating a z-score, which is the sample mean minus population mean divided by standard deviation divided by square root of sample size. If that's my z-score, I should be able to go to my table, find that z-score of 0.45, find out what the area in the tail is. And if I can use 1 minus norms dist or some other Excel formula like that to create a concurrent number, then I know I've created the formula appropriately, and then I can just copy it over. 1 minus norms dist, well, that might be right, that might be close to right, that might be something you can use. If you want to, just compute the z-scores like this and then go to your table in order to find out what the value of your p-value is, that's all right too. Lastly, the thing you put down here in support is your interpretation of whatever p-value you calculate here. So for example, this p-value would seem to indicate not a whole lot of support. If we had a p-value that was like, let's say, 0.001, look over here, there's a whole bunch of these that list it. That's not copied over, but if you want to copy it over, now you can just use the drop down. I'll show you what I did. In cell C11 here, there is this, it's called data validation. Data, come up here, data validation. That cell says that only these 5 values can be in there. If you copy that cell and paste it here, now Excel thinks only those 5 values can go here. With a 0.001 p-value, that would be extremely strong support. If I had the p-value that I had before, some big number, pardon me, then you would have no support. You repeat that exercise across for all these. These 4 cells right here, under population, we are not doing any sort of hypothesis testing of the population to itself. That doesn't make any sense. We just have a bunch of zeros and stuff. So that this part right here, you don't need to input anything for. You will, however, down here and everything to the right, notice these 2 questions are different. The first question says the empirical rule. Go back to chapter 3 or 4, whatever chapter that was. I think it was 3, where we first introduced that. You know how to use the formulas. If you know what the symbols and the vocabulary terms mean, you should be able to just right quick take the information you have, whether it's a mean or a standard deviation or a sample size, whatever you need, and you can just use it that way. Confidence interval as well. We spend an awful lot of time putting together confidence intervals. They have some similar, although not entirely same, rules to follow as the empirical rule. Note that if it turns out you can't calculate some value for whatever reason for any of these things, you are probably best by putting the reason why you can't calculate it, or you can just put NA. If you show me that, oh, you can't calculate it for such and such a reason, or that value is not on the table for such and such a reason, then that works for me for an explanation too. The next batch of questions I had dealt with how to work this one. Again, I'm going to freeze these panes right here. Because when it comes to doing, again, these hypothesis questions, hey, look, now we got that support box down here. When it comes to doing these questions, we look for 3 proportions within the particular sample that we're looking at. So here, if I want to look at the people in their 20s, used, compact, and cane, I'm going to pull up my pivot table here. I don't have anything on here that speaks directly to used, or even 20s here. So what I want to do is get generational in my report filter, so that I'm only looking at the 20s now. So I know people in the 20s, there's 11 people in their 20s. We've got the rest of the crosstabs here, but there's 11 people in their 20s. What proportion of them bought used cars? Well, I have to get used from here. Previous owner, new, used. There we go. Dump location. New. 5 were new, 6 were used. So the proportion of used cars would be 6 out of 11. The proportion of compact cars, 2 out of 11. Portion of cars from Kane, well, I would need to get location in there again. 4 out of 11. Great, so now I've got 3 proportions that describe the subsample of people in their 20s. That's awesome. But what about all this hypothesis testing? Well, you're going to have to choose one of these. Now, there's no field here that allows you to list which one it is. You've got some room down here if you want to keep track of it for yourself. Again, the purpose of this is, 1, to demonstrate your ability to use Excel to answer the questions, but 2, to develop some data analysis. That way you can put it together with your SWOT, and you could have some descriptions there. Pardon me, it's early. I haven't had my go-go juice. So let's say, for one of these, they all look pretty close, but maybe we'll go with this one right here, and we'll say that the proportion of used cars is significantly different for the people in their 20s than it is for all cars. And that becomes our hypothesis. Significantly different, so I just said no to the directional hypothesis. If directional greater or less than pi, I put non-directional. P-value. Great, so now I need to calculate a test statistic, sampling error over standard error, get the area in the tail. It's a non-directional hypothesis, so remember, if you have 2 tails, you gotta 2 tail test, double the area. Double the area. That's if you have a p-value at a tail, and then it's a 2-tail test and a 1-tail test. You have to double that 1 tail to get the total area of the p-value, because the p-value is the total area in all tails, whether it's 1 tail or 2 tails. And then, based on the value of your p-value, whatever it is, oh hey, 0.825, and that's some very strong support. Again, there's nothing for you to indicate which one you're working with here. And that's my bad. I should have included something in there about which one you're going to be testing. Somebody has said before, maybe you look for the one that's most different from the population proportion. That way, you're more likely to have an alternative hypothesis that is supported, so that you have some finding to report in your SWOT. Sure, you can go after the ones with the largest sampling area, or the largest sampling error. That's fine with me. Maybe you've got some reason to believe that's the case. But that's how you complete the rest of the stuff. Again, down here for the using the empirical rule or doing a confidence interval here. We didn't do the empirical rule for proportions. So that is something that should have been blocked out. So don't try to do that. It only applies to the means, which was Q1. So this isn't 100% clean, the version I got to you, even the second version I got to you, and I apologize for that. But I do appreciate your patience and your constant work and effort to try to make this happen and to continue to use Excel and learn this stuff. Oh man, I have the greatest bit of empathy for the people who teach CAD, because this can be a little tough. But you're sticking it out with me, and I appreciate your patience, and I hope that in giving feedback like this, it's what's useful and helpful to you. Outside of that, I'll see you Friday, and best of luck on the project.